What's with the CIDR? The classless interdomain routing. Things were used to be classified and used to be classful. What's with the classless? What happened to the class? Well, it was no longer ruling. Around 30 years ago, it was removed from defining the excessive, exhausting, or let's say the excessive non-investment wasting of IPv4. Meaning that from now on almost every single device that you have in the networks nowadays, because it's a long story, long time ago, it's a story that had happened long time ago, whatever IP address can be designed over whatever subnet mask. So am I allowed to say 10 dot whatever but slash 20 something instead of 8? Yes, this happened. Is that true? Correct. So in classless interdomain routing, we have a couple of things only. Number one, subnet mask no longer is fixed, and you will have flexibility of using it with a prefix. Think of VLSM. The first example was 192.168/24, which was a class C. The second example was 10.something/26. That was classless, acceptable nowadays. So note number one, classes are no longer fixed. Note number two, in the CIDR, we will also have around 4 examples. 4 examples will be fine. So in the 4 examples, we will try to hit 2 birds with 1 rock, and you will see why in the upcoming videos, maybe this one, the next, and the next, etc. But what we will do is that in the VLSM, they used to provide prefix and a prefix length, subnet and a subnet mask, IP and a subnet mask, and they asked for network ID, broadcast ID, valid range of IP addresses. From that, you will understand the amount of useful IP addresses, the amount of employees that this network can cover their computers with. This is what you and I did in the VLSM. The CIDR, it's the opposite. You will be provided with the IP and the number of consumers. This time, please investigate and obtain the subnet mask that fits those consumers the most by wasting the least possible amount of IP addresses. So when they tell me they have a network of 100 computers, in the previous days, a class C, a /24 is the best choice for you, right? Now, no, a /24 gives the total useful number of addresses as 254. You need a maximum of 100. I am wasting 154 excessive addresses instead of investing them, unfortunately. With the CIDR, no. Let's design a subnet mask, a subnet mask that fits these guys, or at least fits a little bit more than 100, just a little bit more. Let's say a quotient, a further, let's say, and just an extra small space, small portion, but let's say, sorry, the word. Okay, not spending, wasting the least possible amount. Wasting the least possible amount based on what follows. Sajjad, use an example of 50, 150, 300, 600. What are those exactly? Those are 4 different networks. Each one doesn't see the other, but we will design subnet mask for all of the 4 of them that fit them so well. The biggest, most important note is that when you design CIDR and you have some networks, you need to start from the biggest towards the smallest. So I will first design a network for 600 component, then 300, then 150, then 50. Let's start with that. Let's see example number 1. Let's take a break, and in the next video, we will continue with the other example. For simplicity, they told us to use 10 dot whatever you like. This time, the subnet mask is unknown. It is unknown. What is known, actually, is that the CIDR block, or the number of consumers, equals, the first example was 600 consumer. Big number, but we are starting with that. It will not be difficult. No, I am not writing the diagram this time of 1111, etc., because I don't know the subnet mask. What I do know, or what I will write, is a new diagram. A diagram of the multiplications of 2 for some amount of numbers. Like what? Like 1 multiplied by 2, 2 multiplied by 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and this can continue for thousands and tens of thousands, hundreds of thousands, millions of numbers. I am hoping that this amount will be enough. This is not an 8-bit. This is just a diagram that I will use based on my needs. So step number 1, the diagram. Done. Step number 2, how many IP addresses you need? All right, that's an embarrassing question. It's 600. So 600 is the number of employees. If I designed, this is why it's embarrassing. If I designed a subnet mask that fits 600, just 600 IP addresses, will it be enough? Why not? What are 2 more addresses that I neglected right now, and they are a must in the network? The network ID and the broadcast ID. So today I am reverting what I did in the VLSM. When I have the number of hosts, I will add the network ID and the broadcast ID, resulting in I need to design a network that fits 602 hosts in total. Obtained. Next, what should we do? Well, next, what I should do right now is that I need to refer to the ladder, to the diagram, and start looking for a number that is enough of IP addresses. Meaning, is an IP address enough for 602 consumers? One IP? One single IP? No. Is 2 enough? No. Is 60 enough? Definitely not. Is 64 enough? Believe me, it's not enough. They will need around more than 500 addresses as well. Is 256 enough? No. Okay, this is going too far. Is 512 enough? No. Is 1024 enough? Well, yes, but leave the but. Yes, yes. So it is enough, all right. But there will be like a 400 excessive IP addresses, extra IP addresses. Correct. If this company expanded in the future, then they will use from these extra 400 IP addresses. So yes, a decider tries to invest as much as possible, but it is not the optimum number because these are the rules of the binary language. That's why it has to multiply by 2. I cannot just write in the diagram number 628 and use it. I just can't. I have to multiply by 2. I have to be stuck between 512, which has a shortage of 90 IP addresses, and 1024, which has an excessive of over 400 IP addresses. So yes, I will take the bigger, not the smaller. So this was step number 3, to compare to the diagram. Step number 4, draw a line between the number that was not enough and the number that was enough. 512 was not enough. 1024 was enough. Step number 5, whatever on the right side of the line, fill it with zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0, and a 0. Okay, this should lead to what exactly? What is your point here? My point is, how many zeros did you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 zeros. The subnet mask is a series of ones followed by a series of zeros. And it's a fixed value of 32-bit. So if you have the numbers of ones in the VLSM, you know the amount of zeros. If you have the number of zeros, you know the ones. Subnet mask. Done. We are done. This is the idea. We are here today, done with it. So I just knew that the subnet mask is /22. What to do right now? Go back to the rules, go back to VLSM. Again, this time assume that you have 10.0.0.0/22 and start taking, let's say, obtaining network ID, broadcast ID, valid range. This is an excellent homework for you. If you did not practice like for 20 examples or 15 examples with VLSM, then this is your chance again to practice new VLSM examples. Because now we just obtained the subnet mask, we know it, go and start the broadcast ID. Hint, it is /22. It fits almost 1024 addresses in total. So it will end up with a broadcast ID that I will show you later. Or if I just wrote it for you right now, let me just write it for you as a hint. And when you finish your homework, compare the numbers here. Compare the numbers in here. The network ID is 10.0.0.0 network ID. And the broadcast ID will be 10.0. This time 22 is 424s. So that will be 355. Broadcast ID. Yes, you will reach a level where by seeing the subnet mask, you will immediately know the broadcast ID. And this comes from practicing and practicing only. All right? See you in the next video.